Hello there guys, welcome back to another epic and extra real maths video. In this video, we're looking at this integral right here. Now, normally people do this integral using substitution, but I'm going to do it with integration by parts. So it's a bit of an unconventional way of doing it, maybe, but it's actually not too bad with integration by parts, and it's good revision for integration by parts too. So I'm going to notice that arc sine x is pretty easy to differentiate. It has a standard derivative. And actually, remember, because we have to think of this as one function multiplied by another, the other function, aside from arc sine x, would be 1 over the square root of 1 minus x squared. And that actually has a pretty nice integral. It actually is arc sine x. So each one kind of differentiates, or one differentiates to the other, and that one integrates to the other. So let me write this down, what I'm talking about. So if we let u equal arc sine x, okay, and we let dv dx equal 1 over the square root of 1 minus x squared, like this, then we can see that du dx, because the derivative of arc sine x is just 1 over the square root of 1 minus x squared, so that's what du dx is going to be. And v, by integrating 1 over the square root of 1 minus x squared, that will actually give us arc sine x. Okay, and then using the formula for integration by parts, this is going to be equal to uv minus the integral of v times du dx. So uv is arc sine x times arc sine x. That's arc sine x squared. And then I need to subtract the integral of v times du dx, which is actually going to end up being, if I slightly zoom out just to get a little bit more space, that integral is actually going to just be, once again, arc sine x divided by the square root of 1 minus x squared. So you might say, oh no, we've come back to the same integral again. But guys, this is a really clever thing that we can do, and we've done this. If you've seen any of my other videos on integration problems, we've done this before. We can actually just add the integral of arc sine x over the square root of 1 minus x squared, and I almost forgot the dx there. We can just add the integral to both sides. So if I just kind of come down here, I essentially have that two lots of the integral of arc sine x over the square root of 1 minus x squared, two lots of it because I'm adding it to both sides, is equal to arc sine x squared, like this. And at this point, you know, we'll do a plus c at the end. But then if we just halve both sides, then we get that the integral that we're looking for, the integral of arc sine x divided by the square root of 1 minus x squared with respect to x. This is just half of arc sine x squared, like this. And then we can finally add our plus c on the end. And so this is what we get. We actually get that the integral of arc sine x over the square root of 1 minus x squared is 1/2 arc sine x squared plus c. And again, the way that you normally would do this is probably by a u substitution. You would probably let u equal arc sine x, and that would be pretty good as well. This is not the only way of doing it, but it's a pretty nice way. I think it's a pretty clever way of doing it. And the reason why this works, and it gives you back the same integral after you've done integration by parts, and then you add it to both sides, the reason why this works is because we're multiplying one function and its derivative, okay? So this will always happen if you have the integral of f of x times the derivative of f of x. You can use integration by parts to do this. So it's pretty cool. Maybe in the future we'll make a video on like kind of proving that, but for now, nifty little example. Thank you guys, as always, so much for watching. I highly appreciate it, and I'll see you in the next video. Cheers.